Hey, hello everyone, welcome to another episode of ML for Noobs. Now, after the last lesson, which went pretty well, except for the fact that I cut out the audio. I didn't have any audio when I was recording, and so that was a major fail. And I'll try to redo the video at some point, but for now, I'm just going to stay up as it is. Because honestly, I just can't be bothered. Anyway, so what we're going to do now is we're going to be doing some practice, all right? So it's great to watch a video and run some commands, but unless you're actually able to do this yourself, you're never really going to get the hang of it. And so that's really the point of doing this. And so I just went ahead and created a new notebook, and I tried creating a practice lesson using a new data set. So something that we haven't used before that's not built into FastAI itself. And so that was a core idea here, right? So let's go through what I was able to come up with. It took a bit of time just to get used to the syntax. Python is pretty different than what I've used before. But anyway, so I just made a copy of the last notebook, and we're going to walk through it now. So the data I'm using is a gender detection face. This is something that I pulled off of Kaggle. So if you look up gender detection face, you can find it on Kaggle. I wasn't able to pull it directly from Kaggle, so I just pulled it and then uploaded it to Google Cloud and just created a public URL. You can actually use this URL yourself if you wanted to get the data. And so all I'm doing here is download data into a path. I'm then unzipping it because for some reason untar data, which is what was used in a previous notebook, it does not support zip files. And since this is a zip file, we weren't able to use that. So instead, I'm just using this unzip command to unzip it to FastAI data. And you can see what that looks like here. So if I SSH into the machine, or if you're using Kressel, you can do that too. So just an update here. I was able to get the Google thing approved, and so I could just SSH into the machine. If you're using Kressel, you'll use something similar. I mean, you won't have an SSH interface, but you'd be able to run shell commands directly from the notebook. All you need to do is prepend an exclamation mark before the command that you want to run. So unzips this zip file into a data directory, as you can see here. It unzips it to this dataset directory, and in there you'll see models trained and valid. And then all we're going to do is set path image to this dataset directory. It already follows the structure that we need, which is 3 folders. The train folder includes all of our, training images. So if I go LL train, or rather, let me just go into dataset. If I go LL train, you'll see man and woman. And then if you pick man, you're going to see a bunch of images related to man. And so all we really need to do here is set the path image to the main dataset directory, and then call get image files on it. And just make sure to pass recurse equal true, just so that it goes through the man and the woman folder. And then when you pick a bunch of names, you'll see that it follows this structure here. Now, obviously, you need to update the regular expression that you're using, and so I made a slight change here so that instead of reading this, it will read the folder name. So folder slash and then take whatever alphanumeric characters exist, and then face underscore whatever the rest of the image. And so here we can see that it's working because when I ran show batch, it shows me an image along with the tag that it identified. So I can see man and woman images are accurately categorized here. So it's properly extracting the images. Then I just ran data to classes, and we can see that the only 2 classes we have are man and woman, so that makes sense. And then we just run the same ResNet learner. So literally copy paste. I changed nothing here. And once I did run that and ran a full 1 cycle, or 4 cycles, I was able to get an error rate of about 8%. Not great. I was actually expecting much better. So I was kind of surprised that it was that bad. But yeah, let's wait until we get to the last bit, because after I ran this, so you run the top losses just to see where it's getting things wrong. You can see here are some samples. And while it's able to accurately predict in many cases, a man is a man and a woman is a woman, it does mess up in some cases. And so these are what the most confused looks like. And then what I decided to do was, okay, let's provide an actual image and see how it ranks that image. So I got an image of PG here, and I loaded it up. You can see what the image looks like. And then what I did is learn.predict on that image. And this initial learner, Resonat34, actually categorized him as a woman, which is obviously messed up. That's not how it's supposed to be. And so, okay, yeah, there's something wrong there. I'm sure we can do much better than just whatever it is. What was this? 8%, I think. Yeah, 8.5%. So we can do a lot better than that, right? And so I unfreezed it and then did the same fitting that we did before and loaded stage 1 and ran the learning rate finder and found that, okay, up until E-3 approximately, we're doing pretty well, and then the loss just goes crazy. And so I ran an optimized version, right? So again, 34, but this time it's optimized, and I was able to get the loss down to, wow, 0.07, which was crazy, right? I have no idea why there's such a dramatic change, but yeah, for some reason it just worked. I really don't understand, because this really doesn't make sense to me, why it would be such a huge difference. And when I do this, so let me try to run this again and see what the output will look like, because when I ran it, I actually got PG categorized as a woman. And so I'm like, why? This doesn't make any sense. You're saying you had such high accuracy. What, 4%? No, 0.7%. And then it turns around and, tells me PG's a woman. Like, there's something wrong there. There's obviously something wrong there. And so anyway, we'll come back to that in a minute once it's done cooking. I'll show you the rest of the results. And I was actually quite surprised. ResNet 50 did a ton better, as you'll see in a second. So same thing. First you set it up without any sort of tweaks. And when I ran that, I got 4% error rate. But the actual prediction was much more accurate. So PG is categorized as a man correctly, and this I presume is the I don't know what that is, but these are really small numbers. I assume it's the loss. I'm not really sure, but you can't calculate loss unless you actually know what the correct category. Maybe it's confidence, in which case this is horrible. Like, you want to have higher confidence, not lower. Anyway, so we got our results again, and here when I run this, yeah, you can see that it's categorizing PG as a woman. Don't know why. And then also really, really small values. I'm not really sure what that's about. Well, anyway, and then yeah. Okay, and then so we ran this and we got 4%, and then I tried optimizing it, and I was also getting 4.3 instead of 4.6. Not a huge improvement. And again, this time it's probably categorizing PG as a man. So I think I kind of have an idea for why this might be going wrong, but I'm not so sure. It seems to me like the images, so all these images that you're looking at are actually randomly sized. So if I go to, let's say, train man, right? So I'm just going to pick, let's say, face underscore 999. So here you can see that the image size is 167 by 238. That's the size of the image in pixels. If I pick the other image, so let's say 997, you can see that it has a different size. So it's 127 by 175. So I think this plays a part. So the fact that all of these images are differently sized, and the fact that they might have different aspect ratios, actually messes up with how accurate the model might be. And so I wasn't really sure how to do this such that we fix all of the image sizes. but that's definitely something that I would want to try. I also don't know if it's properly handling this, because we have a train and a valid directory. It's supposed to use the train directory for training and the valid directory for, well, validation, but I'm not really sure it's doing that, so I can't really tell if maybe there's some sort of overfitting. Should explain why, like why can't it recognize PG as a man? Like that should be easy, right? Why would it be complicated? But anyway, and also another thing is, I mean, the images I'm actually seeing here seem to follow a fixed size. So I don't know if the library itself is doing something behind the scenes to sort of standardize all of the images. Maybe, could be. But if that's the case, then that could explain why the predict thing doesn't really work, because the image size may be different. It may not be doing the same sort of treatment on the predict function that it is to all of the other images. I don't know. Anyway, so that's the result. That's what it looks like, and I was able to successfully classify PG as a man in the ResNet 50 model. And so that's it. That's it for the practice exercise. I'm definitely looking to learn more in lesson 2. This is just very basic, and I really wanted to get around actually loading up the images and doing the unzip, and, making sure that all of that just works, and it seems like it does. And so now what we really need to do is understand, all right, how can we actually get this done, or get a bit of a better understanding for how things actually work. And so that's it, guys. I will see you in the next video where we cover lesson 2. For now, adios.